Welcome everybody to CPI and XCamp's USACO Open Contest Workshop. So from now until 8 p.m., we'll be covering the bronze and silver solutions. So bronze will take about an hour, and then we might take a break before we start silver solutions from 7 to 8 p.m. For bronze, we have 3 instructors from CPI, and for silver, we have 2 instructors from XCamp and 1 instructor from CPI. And as always, after the presentation, you can feel free to unmute and ask any questions, and also type in chat any clarifications that you might need as you're explaining. And then after we do the presentations, we're talking a little bit about the trends of the US Open contest, and then just like advice on how to prepare for future contests. Okay, without further ado, I'll hand it off to Ryan Fu to cover bronze problem 1.
All right, yeah. Let me share my screen and then I guess I can get started. Uh, can you all see my screen?
Yeah.
All right. So I'm assuming you guys have read the problem before, but if you haven't, just as a quick overview, you have essentially a string of both Booleans as well as logical operators, which are and or. And you're given Q queries, which tell you that you're allowed to set from left to right inside your string to either false or true, and you want the entire expression to be equal to false or true, and you're outputting if that's actually possible to do for each of the Q queries. So I guess as with any problem, it's a good idea to like start with the sample to like make observations and to try to like get a feel for the problem. And this is also for people that haven't exactly read the problem yet. So I guess as a first query, we have 1, 1. So we're allowed to change everything in uh, this place, and we want the entire thing to be equal to false. But this actually isn't possible because we process ands first and ors second, and there's already a true statement over here. So no matter what this stuff evaluates to, we'll just or it with the true, and no matter what, the expression will still be true. So as you can see, the first one, it's not possible to make it false. For the second one, we can change 1, 3. Um, and we want it to be true. Again, kind of like because of this true, it'll always evaluate to true no matter what. We can do the same for, or the third query is pretty trivial, I guess. You can change the value of the entire string to false, and then you're done. This query, you want it to be true, and you can change 3, 3. But again, this true here guarantees that the entire string will evaluate to true. So that's also a yes. For the same reason, this is a no. Same reason as the first query. For this one, you want the entire thing to be false. And we can see that if we make this to false, then false and true, since we process ands first, that'll be false. And then false or false is false. So this is actually possible. And then for 5, 5, true, we can simply just keep it as true, and the entire thing will evaluate to true. So I guess one thing that we can observe from this is that since we always process ands first and ors after that, we can break our sequence into a series of first a bunch of ands. Um, so first like a couple runs of ands, and then some ors. So like the structure of the problem looks like this. And to give an example of this in the sample, it'll look um, like this. And this enables us to like kind of visualize the way that we'll process each query kind of efficiently. Now, of course, I guess if you're looking at the subtasks here, it's pretty obvious how to get an O of NQ solution. You can literally just try to change each thing to false or true and see like the output. You do that for each of the Q queries. You'll process the entire string. That's an O of NQ, and I guess the implementation of that can be like left as an exercise or something. But we want to do better than that, and we want to solve the whole problem. So we want to probably solve it in somewhere near O of n time. And I guess this structure of the problem kind of allows us to uh, make a lot of simplifications enough so that we're able to solve the problem. So I guess we kind of have two cases in this problem, right? So case one, and this is actually the slightly easier case, is we want the Boolean expression to evaluate to false. So in this case, if we if we want our thing to evaluate to false, and let's say like our query is from here to here, um, since an or means that since A or B, etc., if even if even one of these evaluates to true, the entire expression is going to be true. So what that implies is that everything to the left of it must be false, everything to the right of our query must be false, and then our query must also evaluate to being false. And our querying evaluating to false, or like the query range, this I guess, because this is our query, so we can essentially combine these into, since we'll have like something and something and then our query and then and the rest of the run of ands. Um, since we can just let our query and change it to false, that will enable this entire thing to be false, because when you have one false in a run of ands, that entire expression will be equivalent to false. So all we need to do to check for case one is everything to the left is false, everything to the right is false, and then you're done, because then you can just set then you're done, because after that you'll just set your query to false and you're done. So that's pretty simple so far. The second case, which is slightly more complex, is if you actually want your thing to evaluate to true. So in this case, again, we can have like our series of runs. Like so. And let's say like again, our query can be something from here to here. So I think like the first thing is that using the same logic as the previous one, if anything here is true, or if anything here is true, and we only need one true outside of our query range, I guess. If anything outside is true, like if there's at least one true outside, then it's possible, because the ORs will just make it so that the entire expression evaluates the true. But if that's not the case, then we have that, oops, then we have that all of these are equivalent to false. That's also false. And so the only way that we can output yes is if we somehow enable this range to be true as a whole, because then we can still OR everything together and it'll still be true. Now, obviously, it'd be better for a query to fill in as true, since otherwise, if it's false, it's guaranteed to be false. But here we still need to check that this range is all trues, and this range is all trues. So, because if those ranges are not all trues, then like if there's one false here, then when we AND everything together, it'll just be false, and then the entire expression will be false. So this is like the first case for outputting yes, and the second case is everything like inside the bounds, I guess, or I'll call these 2 points the bounds, but outside your query is true. So again, we need these to be true. So with that, I guess this is all pretty like high level, but I think it'll make a lot more sense in the implementation. Here's code that gets AC. So you'll notice that there's like a couple of arrays here. I guess I'll explain what they do. So the first thing you need to do in this problem, I guess, is it's important to be able to find like the bounds, like these guys and these guys, because that's the only way you're gonna check if like these are like false or true and all that stuff. And also, since when you're checking true, you also need to check for false and true in that range. So one way you can do that is to have like a left endpoint array and a right endpoint array. And the way that we'll initialize them, or the way that they'll be defined, is left of index is like if your index is here and the first OR is here, it's going to be the last index that's next to the OR. So that's going to be left. It's going to be here. And then right is defined the same way. It's going to be the first one before the last OR. So that'll enable us to find this in this position in O of one time, which we need to do. After that, we have an LF and an RF array. Those stand for like left false and right false. And what that kind of it is, and what we're kind of doing with that is that when we're checking if this is going to be true or not, we need to check if there's a false in here and if there's a false in here. So like I think you can do this with some like range query data structure, like prefix sums or something. But another nice way to pre-compute it is you can just check for every indice, you can just check the first false to the left of it and the first false to the right of it. In that way, if we get our left index here, if we know that our first false is like over here or something, then we know that there's no falses over here and we'll be fine. But if the first false to the left of it is in this range, then we know that we're not fine and we can't AND everything to be true. The same says, and the same goes for the right thing. So for the right index, if we just find the closest false to the right of it, then we can simply check if it's over here, then we're good. But if it's over here, then we're not good, since it'll be inside this range and everything can't evaluate to true. So that's kind of checking for this thing. Now, I think the only final thing we need to check is to check if this is true and this is true, or rather just to check if there's any trues within these. And again, you can do that with any like range query data structure you want, but you can also do some nice pre-computation here. The way you do that, oh sorry, yeah, I forgot to talk about how you initialize left false and right false. But the way you do that is similar to the way you initialize this guy. So The way you do that is as you're iterating, as you're as you're going along your array, if you encounter a false, then your left false of it just becomes this. And if it's a true, then you know that the closest false to the left is equivalent to the closest false to the left of the previous one. Oops. So that's how we initialize left false and right false. For right false, we just go in the other direction. And that's also how we can find the closest OR. Finally, we need to kind of have a nice way to check if there's any like trues to the left or trues to the right. And the way we can do that is to kind of pre-compute. And this is like to the this is to the left, I think. This is to the right. The way we can do that is we can pre-compute how how many total expressions that and to true. That's what val is here. And if it's equal to true, then we can set like our value to 1, and then that'll let us know that there is some run of ands that evaluates to 1 in our prefix, and that'll tell us and that'll give us again a nice O of one way to see if to see if uh, there is a true in here or not, which will enable us to check again for if the left is false and the right is false for the false case. And it'll also enable us to check if there's at least one true outside for the true case. You do that for the right as well. In the query section, we just went over that. But if it's false, but if the left or the right has a true, and if it's false, it's obviously no, and if it's true, it's obviously yes. If that's not the case, if it's false, we can output a yes, but if it's true, we have to check if the falses are kind of close enough to it so that they fall, are far enough so that they fall outside the bounds. If that's not the case, then we can output no, but if that is the case, then we can output yes, and the solution does get AC. Yeah. So if anyone has any questions, I guess you guys can ask them now. Seeing none, I guess I'll hand it off to the next person, which is Max, and I guess I'll stay here for like another 5 minutes just in case anything pops up and you can send it to me in the chat or something. Thanks.